This is the third mini lecture for section 2.4 of the textbook. Now we're going to talk about division. Remember how we defined subtraction as a fill-in-the-blank addition problem? Well, very similarly, we define division as a fill-in-the-blank multiplication problem. If a and b are whole numbers and b is not 0, then the quotient a divided by b, if it exists, is the unique whole number c, so that b times c is a. Okay, so of course it may not exist. We talked earlier about how the whole numbers are not necessarily, the whole numbers are not closed under division. Okay, so when I ask what is a divided by b, that's the same as asking b times what is equal to a. What do I have to multiply b by in order to get a? Okay, and there are three models for division, the first of which is the missing factor model, which matches closely with this definition. Nathan wants to bake 48 cookies in 6 batches. How many cookies will be in each batch? So what we're asking here is 6 times what would be 48? Okay, one way to figure it out would be by skip counting. You could just skip count by 6s, maybe counting on your fingers, and until you get up to 48. And you'll find that it's 8, of course. It's 8 6s. So 48 divided by 6 is 8. And that's because it's 8 that fills in the blank. So you see, when you do division, it's really kind of an algebraic process. You're trying to fill in the blank, just like you do in any algebra problem. Okay, the second model is called the repeated subtraction model. Mrs. Pena has 20 students in her class. She wants to divide them into groups of 4. How many groups will she have in all? So let's draw a picture for 20 students. I'll just do a little circle for each of them. Okay, so there's Mrs. Pena's class. And she wants to divide them into groups of 4. And one way to do that would be, you just form a group and separate them off, and you just keep going until you don't have any students left over. So here's our first group. It's our second group. The third group. Here's the fourth group, and I guess I counted wrong. Here's the fifth group. And then now we're all out of groups. So what we showed here is that 20 divided by 4 is equal to 5. Notice this is a process that you could go through without knowing any multiplication. You could just, if all you have to do is count, assuming you count correctly, which I failed to do a minute ago. Someone as young as 5 years old could do something like that if they can reliably count up to 20 or so. They could do this, hands-on and figure out the answer. Okay, now the next model is often confused with this one, but notice that it asks for the other piece of information. So Mrs. Pena has 20 students in her class. She wants to divide them into 4 groups of equal size. How many will be in each group? Okay, so now instead of knowing the group size, we know how many groups. instead of trying to figure out how many groups, we're trying to figure out the group size. You see, we're looking for the other piece of information. And imagine how you would do this if this was actually your class. You would have to approach it differently from the way we did this problem. So if you take away 4 students, that's not going to help you form a group. So you still have to put them in the groups. So just subtracting 4 repeatedly does not really get you any closer. What we would do in this case is perhaps do what my teachers always did, which was have the student's number off. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And then, whatever number they say, that's their group number. So we could say, okay, here's group 1, here's group 2, here's group 3, here's group 4. And I say to my first student, okay, you go to group 1. And then the second student goes to group 2. And then the third student goes to group 3. The fourth student goes to group 4. And then I get to the fifth student. And they're going to go to group 1. So what's important here as I go through this is not the final picture, but the process. So pay particular attention to that. Okay, and then here's 6, here's 7, here's 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Okay, so this illustrates 20 divided by 4 equals 5. Okay, and that's called the partition model. So remember, don't get these two confused. For repeated subtraction, you're trying to figure out how many groups. In the partition model, you're trying to figure out how big will each group be. Okay, so far in performing this division, A divided by B, we have been looking for a number C, so that B times C is equal to A. What if there is no such number C? Well, we can still perform the repeated subtraction process. For example, let's consider 27 divided by 6. So we start with 27, we subtract 6, we get 21, subtract 6, we get 15, subtract 6, we get 9, subtract 6, and we get 3. And we can't take away any more 6s, so we have to stop there. Okay, we didn't get down to 0, but we could still say that we took away 4 groups of 6, and there were 3 left over. And this process is called the division algorithm. An algorithm is just a process, usually a mathematical process, that involves repetition and takes you from the problem to the solution without you really having to think carefully about the steps. So if A and B are whole numbers with B non-zero, then there exists unique whole numbers Q called the quotient and R called the remainder, so that A is equal to Q times B plus R, where 0 is less than or equal to R is less than B. So we take away groups of B until no more can be taken. Q is the number of groups, and R is what's left over. So from our example up above, the Q was 4, the R was 3, because there's 3 left over. And we can verify that 27 is 4 times 6 plus 3, where 0 is less than or equal to 3 is less than 6. 27 is 4 groups of 6 plus 3.